There are a few things that you'll be dealing with this week, the first of which being inverse functions. And so in order to have an inverse function, your function needs to be one-to-one. What is one-to-one? One-to-one is when a function has basically its domain always producing different y values. So a lot of the time, they use a horizontal test for one-to-one functions. So if you think about a parabola, for example, if you were to draw a parabola is not one-to-one because it does not pass the horizontal line test. Notice that two different x values produce the same y value. So in a piecewise function, when they ask you if it is one-to-one, I typically would just draw myself a little picture to decide if it is one-to-one. I just find it to be the easiest way to do them. So in number 7 that is listed here, you have a line with, at x is 0, you have an open circle, and it has a negative slope. So it looks something like this. And I only want to graph it where x is less than 0, so I've gone ahead and drawn too much graph. So I'm going to erase this side because we want that to stay less than 0. And the rest of it is when x is 0, y is 3, and then to the right of that, it stays a horizontal line. So is this function one-to-one? Yes. No. No, it's not, because this is actually a horizontal line. So you're crossing that line many, many times. So this one would not be one-to-one. Let's graph the other one to be clear. So the next example, you have two line segments being drawn. The breaking point is -3. The first line, when x is -3, y is 0. The slope is up 2 and over 1. And this is staying to the left of that spot. At x is -3 on the second piece, -3 plus 4 is 1. That is not included because there's no equals. And the slope for this is up 1 and over 1. And it has a y-intercept of 4. So is this one-to-one? Yes, because whenever you draw a horizontal line, you are only hitting the graph once at any place. So what is an inverse function? An inverse function can be shown by the symbol f with a little -1 in the corner. Please know that that's not the same as 1 over f. It is a symbol that is designed for the inverse function. So it is different than x to the -1st is 1. F inverse is not 1 over f. They're two different things. Okay, so there are things that must be true in order for a function to have an inverse. Number 1, the domain in the function becomes the range in the inverse, and the range becomes the domain. That's basically because x and y are switching places between a function and its inverse. Number 2, the two graphs of f of x and f inverse of x are symmetric around the line y equals x. And number 3, if I composed f with f of x, f with f inverse of x, in either direction, my answer would be x. So let's take a look at those three things. First, if they ask me to find an inverse of a function, basically your y becomes your x and your x becomes your y. They switch places. They want you to write the answer as a function of x, so I want to get y by itself. So I'm going to subtract 1 on both sides, and I'm going to multiply both sides by 2. That means that the function inverse would be 2x minus 2. Another example, if I'm given the function of f of x equals x plus 3 over x minus 2, and I want to find f inverse and identify domain and range of f inverse, well, again, to switch y and x. So x is going to become y, and y is going to become x. I'm going to go ahead and solve for y, if possible. Okay, so I've gone ahead and solved for y. So now this is going to be my f inverse. And I'm going to pause this, and you can digest that. So you pause it as well. Now think about the original domain of the original function f of x. The domain would be that x can be any number except for 2. So x is an element of the real numbers except that x cannot equal to 2, because you can't have 0 in a denominator. And if you think about the original range, there is a horizontal asymptote at x at y equals 1, because x divided by x is 1. That means that the range for this particular example, because it does not cross that horizontal asymptote, is that the range has to be from negative infinity to 1 or from 1 to infinity. So when we wrote our inverse function, when we're looking at range of inverse function, first of all, I'm going to look at, well, let's look at the domain first. So the domain, originally x couldn't be 2, right? But now, basically, y can't be 2 in the range, because remember we just said that the domain and the range flip for the function in its inverse, because the range becomes the domain and the domain becomes the range. So the inverse function is that we're going to go from, and I just noticed that actually this should be a parentheses. My bad there. So basically my range from the other one is going to become my domain. And my range is going to become my original domain from the first one. So x is not equal to 2, so negative infinity to 2, or from 2 to infinity. So what is a logarithmic function? A logarithmic function with base b can be written as y equals log base a of x. This is the inverse of the exponential function y equals a to the x. So these two forms are interchangeable. So for example, if I said log base 10 of 100 equals 2, I could rewrite that as 10 to the second equals 100. Those two things are interchangeable. So I always think about it as log base b of an answer equals an exponent. So I say that the log answer is an exponent, which you can see if you look right here. This is the log answer, and see where it is in exponential? It's the exponent. The function y equals ln of x is called the natural logarithmic function. Y equals log x. Notice there's no base listed there. It is understood to be a base 10, and that's called the common log function. In the natural log function, ln of x is considered to be log base e of x. So basically, log base e of x can be rewritten as ln of x, and log base 10 of x, we rewrite that as log x. This is the natural log. This is the common log. There are properties of logarithms that you should have already learned before in previous courses. The first is the product rule. That is, if you have two things being multiplied next to a log, such as log bx, I can split that up into two separate logs joined by a plus. Quotient rule, if you have two things being divided next to a log, you can change it into a subtraction. Reciprocal rule, if you have x on the denominator, that would be the same thing as saying that is ln of x to the negative first, and any exponent go to the front, so you can make it negative ln of x. That is also showing you the power rule. Anytime you have x raised to an exponent next to a log, it can be multiplied in the front. Examples. I have 3 of them here. So in the case of ln of 4 plus ln of sine x, because you have two separate logs joined by a plus, you can condense this by making it a single log and changing it to a multiplication between the two things. In the second case, you have a division between the logs. So if you needed to, you could always expand it by saying I have ln of x plus 1 minus ln of 2x plus 3, 2x minus 3. So just like you can condense, you can also expand if you need to. In the case of ln of 1 over 8, if I wanted to try to calculate this without a calculator, I know that I would have ln of 8 to the negative first. That would be negative ln of 8. I also know that 8 is 2 cubed. And I can move the 3 to the front. So it's just showing you different ways that you can express logarithms, just in case you ever need to simplify them and try to combine them with other things.